All right, hi everyone. We're looking at our next part of our transformations unit, which is all about dilations. Now, we have done dilations in the past, so a lot of this is going to sound pretty familiar to you, but let's just review some of the vocabulary that we need to for our dilations. So the first one that we're looking at is the definition of dilation, which specifically is a transformation that changes the size of a figure. All right, now let's talk about scale factor. With dilations, the thing that changes the size is that scale factor, and that is the amount that a figure either reduces or enlarges. And that is a certain percentage or by a certain certain fraction of the original image. So now let's talk about reduction and enlargement again, just to revisit those terms. So our reduction is when our image gets smaller. Now, when we talk about the reduction and the scale factor, so that we can remember, we talked about originally that scale factor, we use the letter K to represent that. So if the scale factor is getting smaller, or if your figures, are getting smaller, then it is a reduction. And that means that the scale factor has to be between 0 and 1. Now, the enlargement is when your figures are getting bigger. Oops, sorry, can't spell. And in this case, your scale factor, the K, will be greater, excuse me, than 1. Now, one last thing to remember about these scale factors when we're looking at finding those values, to figure out whether you have the reduction or the enlargement, we have to find that K, find that scale factor, which goes back to finding information from the new shape, which will have the apostrophe that has got to be there over the old shape. So it's about finding those matching pieces. So now, if there is not a scale factor, or if there is no change, that is our isometry, which the image has no change to it. And that means our scale factor is exactly 1. All right, that's where your translations, the rotations, and the reflections happen. Those are all isometric transformations because there's no change in the size, only its position. Now, when we start doing our dilations, previously we had done all our dilations about the origin based off of that specific location. But when we have dilations not at the origin, we have to use the easiest way possible, which is going to be to use the rise over run, which we saw in slope. Now, just keep in mind though, with rise over run for dilations, the sign is not going to matter. The only thing that is going to matter for us for dilations is the direction we need to move. So up, down, left, right, that's what we have to pay attention to, and that's what we're going to be watching for. All right, so let's try example 1, our first type of dilation that we have here. So dilate the given figure by K equals 2 about the origin. So we have our scale factor, which is 2. It is bigger than 1, so it should be an enlargement. We notice that we've got the origin down here. So that means that we can do exactly what we did last time, that we looked at dilations, and just multiply. So let's get your original one up here real fast. So original A was at -1, 3. And B was at 2, 0. So that's our original. We're going to take these coordinates, multiply each number by the scale factor, and get our new location. So let's see what happens. So for the -1, we're going to multiply it by a 2 and the 3 times a 2. And again, the 2 was our scale factor. So -1 times 2 is a -2. 3 times 2 is a 6. Let's get the next one. Again, the 2 and the 0 both times 2. So 2 times 2 is a 4. 0 times 2 is still a 0. Now let's plot A prime. Oops, and sorry, that should be B prime. Let's plot the new A prime and B prime and see where our final image landed. So the new A is at -2, 6. So there is my A prime. B prime was at 4, 0. And there's our new figure. It is, in fact, twice the length of the original one, scale factor of 2. And even the slopes that we're going to look at later on are twice the distance. So it said starting at 0. So to get to A, we went left 1, up 3. And then if I did it from the same 0, left 2, up 6. So even the rise over run has been doubled. So that's why we talk about using rise over run when your point of dilation is not the origin. Let's keep moving. Example 2, dilate the given figure by k equals 1/2 about the point 2, -2. This time, we are not at the origin. So we have to do two things here. So step 1 is we're going to graph the original one and find rise over run. Once we know what that rise over run is from your point of dilation to each coordinate, then we take that rise over run and we will multiply each one by the scale factor. And that'll give us our new position. So we are still multiplying, but we're not going straight to the coordinate. We have to go straight to the rise over run from the point of dilation. So let's get your original one graphed up here. So our original is at 0, 0 for A, 4, 2 for B, and 4, 0 for C. So that is our original triangle. Now let's plot the point we're going to dilate this about. So point P was at 2, -2. And so there is point P. So I want to get the rise over run from P to all 3 points of that triangle. So to get to A, I have to go left 2 and up 2. So P to A slope, up 2, and left 2. My scale factor was 1/2, so I'm going to multiply both of those rise over run times that 1/2. So times 1/2 times 1/2. So my final position, up 2, cut that in half, I need to go up 1. Left 2 times 1/2, 2 times 1/2 is a 1. Same direction. So from P, we'll go up and left. And there is my new A prime. And we're at 1, -1. Now let's do B. All right, to get to B, we're looking at up 1, 2, 3, 4, and over 2. So P to B slope, up 4, right 2. And same as before, both of these numbers times 1/2. So instead of up 4, we're only going to go up 2. And 2 times 1/2 is a 1. And again, we just go the same direction. The fraction is only getting multiplied to the numbers. So up 2 and over 1. And there is my new B. So B prime. Now let's do C. So I'm having right 2 and up 2. So up 2 and right 2. Both of these times a half. So instead of up 2, 2 times a half is a 1. Keep the up. 2 times a half is a 1 for the bottom. Keep the right. And so there is my new C for C prime. And so now we can see our triangle, the new one that we just drew, it is in fact smaller, a reduction of the original. Let's check out example 3. This time we're looking at a figure and its dilation. We need to find the scale factor. Let's see what that multiple was. So we need to look at all of our original points. So A, B, and C. So our original A is at -2, -2. Something was done to it, and A prime is sitting at -4, -4. We need to figure out what the scale factor is of this. So we're going to set up an equation. We'll start with the x's. So that means we'll use the 2 and the -4. So -2 times my scale factor is supposed to give me -4. So just like we would any equation, divide out that -2. And according to that, my scale factor is a +2. Now we're going to check the y's. Same idea, -2 times my scale factor is a -4. Divide out that -2, and my k is a 2. So there is our scale factor, a 2, for the point A's. We need to check all 3 points to make sure they all have the same scale factor. So now we'll check out B. The original B is at -1, 2, and then B prime, -2 and 4. So same process, start with the x's. -1 times k is equal to -2. Divide out that -1. And my k is a 2, so it works here. Let's check the y's. The 2 and the 4. So 2 times k is 4. Divide out the 2. And my k is a 2. So it does work for that one. Now let's check C, our final point. So original C is at 2, 1. And then C prime, 4, 2. All right, let's start with the x. So 2k is equal to 4. Again, we're starting with those. Divide out your 2. And k is equal to 2. So far, so good. Then we do y, 1 and 2. So 1k is equal to 2. Divide out the 1. And same 2. If these scale factors do not all come out to the same value, then we do not have a scale factor. It is not a dilation. So for this, my dilation is an enlargement with a scale factor of 2. All right, now let's check out our next example looking at dilations and similar figures. So when we do the perimeter of our figures, these scale factors, what we can use to find it, and it does not change. So it will stay K. But when we do the area, this time the scale factor will be squared. Meaning K, take your scale factor and square it. So let's see what happens first with perimeter, and then we'll look at area. So the perimeter of triangle K is 20. That is our original one. Perimeter is 20. Find the perimeter of its image, K prime, after a dilation has been performed. So we need to get the perimeter of the bigger one. And that's what we're going to try to find. So step 1, we've got some steps here to follow. Step 1, find the scale factor. So K equals. Now, to find that scale factor, it has to be from the dilation point. So from the point. So let's go back to our picture. So we've got our dot here. There's our dilation point. To get to K prime, we went 7 whole units. Now I need to get to original K. Well, if all the way across was 7, 5 of that was used up between the two shapes. So 7 minus 5 means my leftover is a 2. So we need to make our scale factor. Remember, scale factor is new over old. And new will always come from the apostrophe. So 7 over 2. There is my scale factor. Now, since we're dealing with similar figures, we can write our proportion. So use your scale factor, 7 over 2. And now the perimeters. The perimeter they gave us was the old, so we need the new perimeter. So again, new on top, old on bottom. So we need the perimeter of the new, and we have the perimeter of the old. Now we have a normal proportion here. Cross multiply, and we can solve. So 2 times P is 2P, 7 times 20, 140. Divide out the 2. And our perimeter is 70. Now let's see what happens when we deal with area. So similar first couple of steps. Step 1, find the scale factor. So in this case, we've got matching sides. We've got 15 and 5. So 15 over 5, simplify that down, 3 over 1. Second thing is to square it. So my K So if my K is 3 over 1, we're going to square that. So 3 times 3, 9, 1 times 1, 1. And then our last thing is to write the proportion and solve. So we start with our scale factor, 9 over 1. They told us in the figure that the original was 12, which goes on the bottom. And I need the new area. So cross multiply again. 1 times A, 1A. 9 times 12, 108. And this time we were in meters squared. And there is my total area for the new figure. Now we don't need the 1 in front of this A. So I am going to go ahead and just erase the 1 there. But that is, again, how we find our area. So guys, I hope you enjoyed learning a little bit about how we find scale factor with dilations, especially with perimeter and area, because that part is relatively new. So please don't hesitate to reach out to me if you have any questions at all.